Yeah. All right.
A very good evening to everyone. Welcome to the lecture series of ChemPlus 2022. Today we have Sir Ram Gandikota with us, who is going to speak on chemical engineer's journey. Sir will share on how chemical engineering served him well in finding and shaping his career. This is surely going to be a very wonderful talk for all the chemical engineers out there, including me. So before we get started, I would like to give a small introduction about Sir. Sir Ram Gandikota is a senior engineer at Texas Instruments. He has close to 2 decades of experience in all aspects of semiconductor wafer fab engineering, such as CMP, diffusion, implant, photolithography, plasma, thin films, and more. Prior to that, Sir worked at Schlumberger for oil and gas services, Honeywell for industrial controls, and IT technologies for supply chain optimization. He earned his Ph.D. in chemical engineering from the University of Minnesota and bachelors in chemical engineering from IIT Madras. So, sir, we're good to go. You can start.
Okay. Thank you. Thank you for the introduction, Sejal. Really appreciate it. Is my screen, is being shared? Is that correct? Or can you see my screen or no?
No, sir. I can't.
No? Okay. I guess I clicked the stop sharing button earlier. So let me see. Share screen, right? Yeah. Share screen. So yeah. So right. We are good now? Yeah.
Yes, sir.
Okay. So folks, thanks for having me. So my intention being here is to, hopefully I can inspire somebody to pursue this path, right? Take you in one of the directions that I happen to be. So anyway, first of all, the disclaimer, right? This information is being provided to you for the benefit of the students and for educational purposes, and need to be used accordingly, and no commercial motives, right? So so it's essentially how my chemical engineering education and experiences shaped the way along in my career, right? So that's a train of thought we'll be pursuing today. So before jumping in, right, I'm at Texas Instruments right now as a senior engineer. So let me actually show you guys a few video clips that may enthusiasm and put some excitement into it, right? So let me see what I can. Yeah, there you go. So let me start off with this one. I'm sure. One second. Let me. Do I need to do that, right? Yeah.
All around us, making life better on Earth, advancing our knowledge of the planet we call home. Our technologies are ushering.
Sir, we're not able to see the video.
Technologies map the ocean floor and help increase farm yields on land. High-speed data acquisition and transmission capability enable broadband access to the furthest regions on Earth, and power management technologies will power multi-planetary exploration deep into our solar system. That's why TI is pushing the limits of operating in the harsh environments of space. Our radiation-hardened and radiation-tolerant products, along with our deep system expertise, help you design spacecraft that will operate for decades. Our inventory of space-grade products is available today to meet your mission-critical requirements of tomorrow. Create systems with greater integration, increased power density, highest precision accuracy, and high-speed throughput. Texas Instruments, your partner in engineering the next frontier.
All right. So were you able to hear that a little, or was there any challenge? Can I get a?
So we were not able to see the video, sir. We could hear only the voice.
Oh, so basically, my screen was not, that particular screen was not shared. Is that right? Is that the problem?
Yeah. Yes.
Okay. So apologies for this technical glitches, but let me try that again. I guess how to do a okay. Maybe stop share and then share screen, I guess, and then I thought this was the one, right? You can see that now, correct?
Yes, sir.
Yeah. Can you actually see the screen now?
Yes, sir.
Okay, thank you. Yeah.
We can't hear now, sir. So I
Is it good?
guess we can't hear.
What is it, ma'am? I didn't catch it.
We
You can
can't.
hear or
We can't hear. We can watch the video, but can't hear.
oh boy, that's sad. Let me see. I mean, why is that? Yeah, everything is on. It appears to me. What about now? Even now, you could not hear. Is that right?
There is subtitles, sir. We can read the subtitles, so it's cool, I guess.
Okay.
Sir. You can just play the
Okay.
video.
Yeah.
Where multi-spectral imaging technologies application for high-speed data acquisition and transmission capability, broadband access,
Okay. Oh, I don't know.
furthest regions on Earth, and power management technologies will power multi-planetary exploration.
It's audible now, sir.
That's why TI is pushing the limits of operating in the harsh environments of space. Our radiation hardened and radiation tolerant products, along with our deep system expertise, help you design spacecraft that will operate for decades. Our inventory of space grade products is available today to meet your mission critical requirements of tomorrow. Create systems with greater integration, increased power density, highest precision accuracy, and high speed throughput. Texas Instruments, your partner in engineering the next frontier.
All right. Well, let me see. Go back. So let's actually probably go to this one. Okay.
At Texas Instruments, our passion is to create a better world by making electronics more affordable through semiconductors. As the building blocks of modern electronics, our semiconductor technologies help customers develop solutions to the world's toughest challenges, enabling smart medical devices, automated factories, more efficient appliances, and making vehicle electrification possible. Each electronic device you interact with can have tens, hundreds, or even thousands of chips inside, translating signals from the physical universe into digital data and back again, adding intelligence and new functionality to things we use every day. And all of this is possible because companies like TI have been engineering progress for decades. The vacuum tube was once at the heart of all electronics. The first time, entertainment and information could be transmitted and received in real time. In 1954, TI engineer Gordon Teal introduced the world's first commercial silicon transistor. Electronics became personal and could be held in your hand, and things never before imagined were possible. 4 years later, in 1958, TI engineer Jack Kilby combined multiple transistors onto a single piece of semiconductor material to create the world's first integrated circuit. The chip that Jack built changed the world forever. Radar systems were made more reliable. Spacecraft were built with smaller, lighter, more dependable components. Computing power that once cost millions became more powerful, affordable, and fit in your pocket. Through decades of progress, our innovations continue to make electronics more accessible to more people. And today, semiconductors are so affordable that they're being added to everything. home automation makes the places we live more convenient, energy efficient, and safe. Portable medical devices monitor and transmit vital health data in real time. Cars equipped with sensing technology make driving safer than ever before. Industrial robotics make factories safer and increase productivity. Entire cities are smarter, more efficient, and more connected. Where we were once limited by technology, we are now limited only by imagination. At TI, our passion is to create a better world by making electronics more affordable through semiconductors. We think of it as engineering progress. We've been doing it for decades. We continue today, and we can't wait for tomorrow.
All right. So, yeah, let me see. Let me go back here. How many folks can actually, I mean, you could see, but you could not hear, or what exactly was happening?
It was perfect.
It was fine?
Perfect. Yeah, yes.
Okay. So you could actually see
Yes,
and hear this. Okay.
Yes.
Okay. Okay. Excellent. Thank you. Yeah. So that's better then. So I hope those two little videos kind of give a little perspective of how TI and in general people in TI think about the world around us and basically what we try to accomplish, right? And then how do we do it and things of that nature. If it's looking good, let's do. Let me see. Let's actually then probably go to one more. Yeah. So right. So let me actually help you guys with this. Yeah. Get an idea of the TI manufacturing tour.
Welcome to TI's Worldwide Manufacturing Organization, where we manufacture, assemble, package, and test TI's industry-leading semiconductor products.
Can you guys see and hear?
No, sir, we can't see.
We can't see. Okay. So again, I'm doing some. Yeah. 1 second. Yeah. So maybe I had to stop sharing and then share that particular one. Looks like to me. Apologies again for that. So let me see. So yeah, stop sharing and then share screen and I believe this one was the correct one. Let me see. Right, you guys can see the. Okay, 1 second. I'm not sure which screen you're able to see. So let me do one more thing. Stop sharing. So where is my video? Yeah, or maybe this one. Not this one. Yeah, manufacturing. Let me pause that and then come back to this. And this is in a mode. Okay. Where did my share option go?
Just make a click on the screen so you can find.
Here, let me minimize this. This one, no. No, minimize this. In here, where is it? I'm not able to now go back to the Zoom thing here. Let me see. This is okay. Maybe I need to do something here. Yeah, maybe. Yeah, that's right. That's right. Okay, this is better. So now start sharing. So I need to see which one is the correct one, right? So that did not work earlier. Okay, maybe this one will work. And so now go back. No. Go back here and then try this. Does it help a little? Can you guys see anything?
Yes, sir. Yes, sir. We can watch.
You're
Inside,
able to?
look inside IT manufacturing, AIT manufacturing. Look inside.
Okay. Does this help?
Did it just increase the volume, sir?
What was the concern?
Volume, sir.
Volume. Well, I didn't do anything different, but I guess. It's a max. It's a max. No?
I can barely hear, sir.
You can't hear anything? Is that correct?
No, no, sir.
Can you hear me?
Yes, sir. I can hear you.
Okay. Well. Let me see. Let's do. I'm not sure. Just watch it. Otherwise, for the moment, right? It would be nice
Yes,
to
sir.
hear. Yeah, and we'll see what. All right. Okay. So, the concern was you could see, but you could not hear. Is that right?
Yes, sir, kind of.
Okay. Oh, I mean, all right. So what we would do is, let's get back to that. Probably I need to share the right screens, I guess. So let me again share. This time, I'm assuming the main one, right? So if I do that, you should be able to see whatever is in here, correct? So you're able to see my slides?
Yes, sir.
Okay. And you can hear also, right? Correct?
Yes, sir.
Yeah. So let me see whether if I play this now again, whether you'll be able to hear that at all. Um, so let me go there. Uh, yeah. So if I do this and then get out of the mode, right? Oops. Okay. So if I do this, can you hear? Can you hear now?
No, sir.
Okay. You can't hear, right?
No, sir.
You cannot hear.
Yes, sir. Not.
Okay. Okay. All right. Okay. Well, this is actually, hearing is also important, I guess, as much as you have seen. But let me see. If I minimize like that and then play, can you hear? No?
No, sir.
So so maybe it is coming from somewhere else. I'm not sure where the audio is getting picked up from. Um, uh,
Yes.
Miles, however, TI's Dallas headquarters.
no? Yes or no?
No.
No. Okay. I'm not sure. I mean, right? Okay. All right. So I guess we'll pause it. We'll get back to what we're talking, right? So I hope you got some idea about, the overall picture of the wafer fab, right? And so how actually TI probably, let me actually move this here. The key facts are essentially about TI was founded almost close to 90 years ago, right? So we are into reaching we'll be celebrating 100 years pretty soon. It's headquartered in Dallas, Texas, and we got about 31,000 employees, right? And in the US about 13,000 in Americas, right? And 16,000 in Asia Pacific, and 2,000 in Europe. And one of the bigger point is actually TI has about 15 manufacturing sites worldwide. So the wafer fab environment you have seen, those are the examples from the North Texas sites here in closer to Dallas. But of course, there are fabs around the world, right? So that is a competitive advantage for TI. So this is the overall map, right? In terms of, we're all, so this is the focus area in Dallas. But at the same time, we have fabs in Mexico. We have one in Utah, one in, Portland, Maine, and then, one in Freising, a couple in Japan, right? And, Chengdu, China, and then, in test sites in, assembly test sites in Malaysia, and, that areas, right? But it's very clear. You see that there is none in India actually, right? Texas Instruments has a design center in Bangalore. So some of our ECE, Electronics and Communication Engineering graduates actually go to that part of the design center. Several people from who are our alumni, and then and also continuously they do that. But as far as the wafer fab is concerned, so with the current initiative that the government of India is taking, hopefully it will set the roots for the process, and eventually something may happen, and hopefully you folks out there, right, the young engineers who are coming out can actually participate in that activity, right? So you could be spearheading that. In terms of revenue wise, it's about $18 billion per year, and R&D spend is about a little bit more than 1.5 billion, and mostly around industrial automotive electronics, and recently also a lot in personal electronics, right? So that is a type of the product that gets manufactured in the wafer fab you're seeing, right? And TI is also actually very community conscious company. So it participates, in several activities that help the community we serve in and operate, right? In during 2019 and after that during COVID and other places all times also, there were several contributions. Okay, having said that, so let's actually go to what I've been doing, right? So I did my, as I was introduced, I did my undergrad in 1993 pass out from Chennai, just like, some of you guys, and bachelors in chemical engineering. And then I came to University of Minnesota, the chemical engineering department for my direct Ph.D. program. But nevertheless, with the interest in modeling and controls, I spent time in the electrical department as well, in signal processing and controls and things like that. After that, I worked, I moved to Texas essentially, and then, spent most of the time in Texas, just moving around a little bit in Texas. So I was in supply chain optimization, essentially, mathematical modeling, CPLEX, and then, some heuristics and things like that. And I was also in oil and gas industry, right? They do something called stimulation, means that essentially how to increase the effectiveness of the oil well, especially relatively older wells, right? So that you can increase the porosity and then, actually get more oil out of those wells. And after that, I came to Texas Instruments, and I've been in, TI wafer fab since then, right? So I was involved in several activities in the system process control area, equipment control area, statistical process control, statistical factory controls, improving the process yield, modeling of the processes, and and the associated engineering, right? So as a chemical engineer, you actually get to do a lot of things. So let me highlight, some of the major activities, how a wafer fab operates, right? Of course, like anything else, leadership is essential, right? At the end of the day, leadership is what is actually setting the vision, the strategy, and so on. Great leadership is essential. And great, of course, the management skills, and then, the financial backing for what the mission is. And then, and once these basic elements are in place, remember, you're in the business of making electronics, right? And a wafer fab is the first part of the that phase. Essentially, you take a raw silicon wafer, and then and printing the circuits on that, right? And then you cut them into dies, and then package, and then test, and then eventually sell, right? So to do that, of course, the product engineers and test and development engineering group typically constitutes at least in the beginning some electrical and electronics folks. But a person who spent enough time in the wafer fab can actually play those roles as well, right? So and of course, there's a lot of planning involved, simply because it's a supply demand match. At the end of the day, it's all about supply demand. So what is the demand of the electronics? What are the products the market is requesting, right? And then how do you meet that demand with the supply, right? And of course, the manufacturing organization itself. So when you say manufacturing, you're talking about actually the people or related equipment that is required to move the wafer from the beginning of the line to the end of the line, right? So wafer fab, to actually get a quality wafer out of the fab from a raw wafer that is sent in, it takes about 200 steps and about close to 2 months or more. Okay, so it's a quite a intensive activity, right? So consequently, you may need a lot of people too in some cases, right, to actually do that action. So that all comes under the manufacturing group. And you need, of course, equipment. Equipment engineering is actually the tools you're using for each of those processes. So I'm not sure whether you guys got to catch anything from the video. Probably, if you did, you would have seen that there are several steps that a wafer goes through. It goes through something called photolithography, right? Photo, we call it, right? Where you actually are patterning, laying the circuits basically, right? And then it goes through plasma, CMP, chemical mechanical polishing. Plasma is essentially etching things away, right? And then thin film depositions, both PVD and CVD. So that's a metal deposition and dielectric depositions, right? And then diffusions. These are actually tall furnaces, vertical furnaces, which are can do different types of low pressure LPCVD, right? Sorry, I put it as LCPVD. It's actually LPCVD, low pressure chemical vapor deposition. So you can have a poly deposition, nitride, chaos, atmospheric oxidation, right? And so essentially you're getting certain desired thicknesses out of that. You have surface prep, essentially cleaning, right, of the wafer for the subsequent steps, preparing it, and then implant, which is actually the dopants need to be implanted in, right? Of course, metrology tools, which are actually using the CDs. The photo CDs are electrical CDs, or the thickness measurements and things like that, and the yield enhancement group, right? The whole objective is actually make sure these things work, right? And if you have defects and particles, the circuits are gonna are not functional anymore. So you got to basically make sure you don't have particle defects, and of course factory controls, where actually you're controlling the whole thing and then trying to make sure that things are processing per spec, right? And of course pumps and then other workshop maintenance and so on, right? So this is all comes under wafer fab engineering. So all I listed here from top to bottom here, yeah, I didn't mention. Probably another important thing is actually the utilities, facilities, and so on, right? Where you need to supply actually, you need a variety of gases, variety of chemicals, ionized water, right? And then solvents, resists for the photo, slurries for the chemical mechanical polishing, targets and kits for the PVD, CVD depositions, right? And in some cases, it's a finite purity is required, right? So that's 99.999999. So for example, if you remember the COVID situation, right? When you needed oxygen, there were certain plants that were actually built for the supply of the oxygen, right? Now the situation is a little bit better because you managed to actually get these plants online. But those plants are maybe 2 nines purity. Now imagine you need to do the same thing for 5 nines, right? So there will be a lot of you can imagine distillation involved in all that, right? Making it gaining purity levels as you go by. So a chemical engineer can actually play a role anywhere in all of these activities. You can actually step in and then start contributing in all these areas, right? And once you spend enough time and master what is going on and get used to the world that you're in, and of course you can actually start doing other activities as well, right? And eventually go to the leadership roles. So this offers both a mix of applying the science, engineering, and technology that you have learned or going to learn more in that space, and also an opportunity to actually eventually grow as a leader as well, right? So it's an opportunity in one place, pretty much. You can contribute and deliver to the bottom line, right? And eventually grow. So that is what the aspiration of most of the young folks, right? I mean, you want a well-paid job. Everybody likes to getting paid, right? And you want a little respect in the society, right? So you've been a great achiever. Some of you, coming into IITs is a big achievement, right? And now, getting through that, and of course, I'm saying even any undergraduate performing well is a great achievement, right? And then going through all that and eventually grasping some of the fundamentals, and then probably pursuing a little bit of higher studies if needed, right? And jump starting some of the activities that are not already there, right? So this should give you some idea that maybe this part of the ecosystem is not completely developed in the Indian subcontinent right now, but there is a great potential. And realizing that potential depends on young engineers like you all, and then your determination and your ambition, right? So the world, as you can see, the rest of the planet, is able to make this happen, and there are enough reasons and motivation for why it need to happen, right? So it's a matter of now, putting together all the will and making it happen. So that is how I see, how these things can come into existence. They are a little bit capital intensive. There are a lot of other aspects involved, but eventually the ecosystem need to happen. So probably I will leave it here because I think we have only about 17 minutes or so, right, for question and answers. So I'll open for any questions. Is that okay, Sejal? Can you hear me?
Yes, sir, yes, sir.
All right. Nobody has any question, I guess. Is that right? Can you hear me?
Yes, sir, yes, sir.
Okay.
Can you hear me, sir?
Yes. Maybe I need to. Let me minimize this. I don't know whether that helps. Yeah. So I think this part of the communication is fine. I'm hoping that you could hear me. And if anybody has any questions, please post it on chat or pass it on to Sejal, and then I can try answering that. If somebody have a strong desire, and because it's I want to actually answer some of your thoughts that are in your mind and the questions that are arising in your mind. So feel free to fire any question that you may have.
Hello?
Yes.
I got disconnected.
So you got disconnected? Okay. I didn't click anything, right? Yeah. So okay. Yeah.
Yes.
Yeah. Okay. Okay.
So there's this question: how did you find your interest in semiconductors, being a chemical engineering?
Okay. Interest in semiconductors. Yeah. So so when basically, though we do for example in the undergraduate chemical engineering, right, you basically develop some fundamentals, and and then and after that, which is all traditional in nature, right? Most of the routine traditional chemical engineering problems you try to tackle. But once you're entering a grad school, Minnesota was a chemical engineering and material science department. So it was a very good program for chemical engineering and also for material science. So you get to actually interact with a lot of material scientists around you, right? And it happened that there were people who actually worked on advanced materials, and there were people actually from the department in the past who worked on semiconductors from a chemical engineering perspective, right? As you see, I mean, I just commented, there are so many things a chemical engineer can contribute, right? It's actually you are very valued to make all this activity happen. So consequently, after that particular faculty member moved to MIT, I presume. But nevertheless, that is where I first, semiconductors being an alternative came to my mind. And then of course I was doing some, independent research and and trying to gather some information and so on. But it really, so I was and continue to do my work, the traditional work I was pursuing. Later on, after my couple of jobs, that is when I ran into the opportunity. Then I realized, that hey, I can actually get into. You can actually get your foot into the door by several means, right? So and then you start applying, you start succeeding, you do bigger and bigger projects, and then you'll realize that more straightforward thinking. You already know that you have enough information, and you're back in those days the connectivity was not that much, right? So now actually you can hear from people like me or several others, and then look around and quickly realize that the entry point you can actually really get it in many ways, and but what can happen is you will be basically most likely looking at things in a how not from a more fundamental angle, but more of a practical and meeting the requirements now type of a thought process. But if you can actually get a deeper education, then you get to even look back and say, hey, how are these things designed? I mean, is there a better way of especially when you're working through these things, right? So at a design level, you'll be able to play a role of these processes and so on and so on. So that's the opportunity you get. So these are the different ways one can run into this. So yeah, you're about it's been in early 2000 is when I got into this industry. So the opportunity came along, and then I made the move. Yeah. I hope that answered the question a little bit. Yeah.
Yes. Also, sir, like, do you regret not joining electrical engineering?
What is that?
In your, do you regret not joining EE?
Oh, well, actually, as I said, right, I was in the chemical engineering department, and there is the computer science and electrical engineering department was nearby, and some of the experts in controls area theory, right, and systems area were all in electrical engineering. So that is the reason why we started taking classes in there, and eventually a degree too. Yeah. So that's how it happened. So as you can see, there was a lot of interaction between chemical engineering department, material science department, electrical engineering department, and then it was a very and the departments were reasonably close, right? So the curriculum is free enough to take classes in the areas you're trying to pursue. So that flexibility essentially helped me to do this. You're right. I mean, if I look back into my hostel days, the 2 years senior to me were all electronics engineers, but we never talked much about any of this, right? So I was a 1993 pass out. So so the 90 and 91 batches actually, right? I mean 89, 93. So the 90 and 91 pass outs were electronics from Saraswati Hostel in IIT Madras. But those days, you don't do much of a technical conversation at that point. But later on, I've noticed that seen several people contributing in many ways. So you will probably see even more now that the intake is more, and then your alumni is more, right? So and you're able to actually gather information more, so you can quickly see the trails of that how the alumni and then your fellow engineers, fellow students who are training themselves in different areas, right, converge on to a practical application in industry, and basically need to work together to make things happen. So that's another interesting thing that you'll see once you get into the real world. Yeah.
Yes. Yes, I don't think so. We have any more questions here in the chat. So
Okay.
we'll wrap it up, sir. Thank you very much for joining us today, sir, and for the amazing talk. I hope the audience and the participants really did find this very insightful, and especially me, being a chemical engineer, I really did find it very useful, sir. So thank you very much for joining us.
Sure. Really appreciate you guys, giving me the opportunity. I hope it helped you out a little. I hope some of you actually, pursue careers in this space, and wish you all luck. All right. Thank you very much, and I'll stop at this point.
Thanks.
Yeah. Thank you.